So today's class we will see these topics: full functional dependency, partial functional dependency, closure of a functional dependency set, different inference rules, then equivalence of functional dependency sets, then cover of functional dependency set. Okay, so first thing is, what do you mean by full functional dependency and partial functional dependency? They are under the same part, full and partial functional dependency. Okay, assume that you have this particular relation with 6 attributes: SSN, P number, hours, P name, P location. Okay, this is an example relation. Say the key of the relation is SSN and P number combinedly. Okay, these are the key of the relation, because if you are mentioning a relation schema or relation state, you have to mention the primary key. So SSN and P number combinedly are the primary key for this. Now, what do you mean by full functional dependency? Full functional dependency is something from which you cannot reduce any of the attribute. Fine. That means, say I have a functional dependency SSN, P number combinedly determines hours. Hours is the attribute, this one, this side, this is termed as, suppose X, suppose I am terming this to as X, this is as Y. So X determines Y means functional dependency exists between X and Y. Okay, so let's see whether, first thing is whether there is functional dependency between these two or not. SSN P number uniquely determines hours or not. Take any two combination, whether they are repeated. If they are repeated, these two sides should be equal. So here 1 2 3 4 5 6 7 8 9 1. Okay, is this two value repeated anywhere? 1 2 3 4 5 6 7 8 9? No, it's not repeated. So fine. Now check with this: 1 2 3 4 5 6 7 8 9. P number is 2. Whether this is repeated anywhere else? No, so no problem. This one, so none of the rows are repeated, so it's fine. You can take this as a valid functional dependency between SSN P number with hours. Okay, because here if it would have been any other row, suppose here I would have written 1 2 3 4 5 6 7 8 9 1, that means this tuple is repeated here, T1x equals to T2x, then here it should be 32.5, else the functional dependency will not hold. But there is no such case where T1x equals to T2x, so no need to worry about y side, T1y is equals to T2y or not. So functional dependency automatically exists. That you have also seen in the last class, that this is a trivial kind of thing. Okay, so now what do you mean by full functional dependency? Full functional dependency says that removing any of the attribute from this side, if it is a combination of attribute, the X side, then you remove any attribute, say this one or this one, then still the functional dependency will hold. Okay, suppose that means I am removing P number from this combination, so my functional dependency will be between SSN and hours. I have removed P number from the combination, so is the functional dependency still true or not? If it is true, that means if still the functional dependency holds, that means this was a partial functional dependency. That means this was not required, unnecessarily or redundantly we had put it. Okay, that means even if you remove this particular attribute from the combination, still the functional dependency is holding true. Okay, say, so now you find whether this is true or false. SSN determines hours or not. SSN determines hours or not. Now this is X. Previously this was combinedly taken as X. Now I am saying I have removed this, only this part is X, this part is Y. So 1 2 3 4 5 6 7 8 9, where else it is there? This is there. Here T1 Y is 32.5, because this I am terming as T1. Okay, say this is T2, so T1x equals to T2x, that is fine. Whether T1y equals to T2y, no, this is not true. So functional dependency does not exist between SSN and hours. Okay, that means removing this from the combination is invalid. That means it is making the functional dependency invalid. If you are removing this from the combination of SSN and P number, then SSN alone cannot determine hours. That means this is partial functional dependency. Similarly, you try to remove SSN, keep only P number and hours, whether this is holding true or not. You check P number and hours. 1 32.5, 1 is there 20.0, so these two are not equal. That means functional dependency is not holding between P number and hours. Okay, so removing P number also is saying that this will no longer be true. So you remove, if you are removing the functional dependency from this, or sorry, the attribute from this, only SSN cannot determine hours. Similarly, if you remove SSN from this, only P number cannot determine hours. Okay, so there is, this two has to be present combinedly. Okay, alone they cannot determine hours. So this is a full functional dependency. None of the attribute from X side can be removed. If you are removing one, the other cannot determine the Y. Fine, this is full functional dependency. But say the case of SSN P number and E name. SSN P number and E name, whether this is full functional dependency or partial functional dependency. Partial functional means if you are removing one, still the rest can determine Y. Okay, so suppose I am removing P number, so can SSN alone determine E name or not? See from the example, SSN E name, whether this is true or not. 1 2 3 4 5 7 8 9 is Smith. Okay, so T1x is 1 2 3 4 5 6 7 8 9, T1y is Smith, T2x is say 1 2 3 4 5 6 7 8 9, these two are equal, so these two must be equal. Yes, these two are equal, so this is true. Again you check for all, 6 6 8 8 4 4 9, this is not repeated, so no need to worry. 4 5 3 4 5 3 4 5 3, this is again repeated here. That means T1x equals to T2x. Now T1y should be equals to T2y. Yes, these two are also same, so T1x equals to T2x, T1y equals to T2y. So functional dependency exists between SSN and ename. Okay, that means if you are removing P number from this combination, SSN alone can determine ename. So this is partial functional dependency. Again you check for this one, that means you remove SSN from the combination, only P number, only P number, ename. Got? determine this whether p number ename can determine p number and ename. One is Smith, one is English, so these two are not same. So if you are removing p number, sorry, if you are removing SSN, p number alone cannot determine ename. Okay, so that means p number was the extraneous attribute. From this combination, if you remove p number, still the functional dependency is holding true. That means this one is the extra attribute present in the functional dependency. Even if you are removing this, the functional dependency is still holding true. That means this one is an example of partial functional dependency. Okay, you have to check like this. Remove one attribute. If even one attribute can be removed, that means if it is still holding true, then this is a partial functional dependency. Or else if removing any of them is hampering the functional dependency, that means that is a full functional dependency. Okay, this was your partial and full functional dependency. Now closure of a functional dependency set, this one, the third one. What is mean by closure of a functional dependency set? So it is denoted by f plus. F is say a functional dependency set. Functional dependency set means there are some functional dependencies. Suppose S tends to A, B tends to C, A tends to E. Likewise, this is a set. So a set where multiple functional dependencies are there. So a functional dependency set, say, is named as F. The closure of this set will be termed as F plus. Okay. So how do you determine this F plus? It says that all the dependencies that include F as well as the dependencies that can be inferred from F is the closure. Okay, so function dependency or F plus is consisting of all functional dependencies in F, also all functional dependencies that can be derived from F. Okay, say one example. A function dependency set is like this. SSN determines ename, date, address, department number, then D number determines D name, manager number. So these are the two functional dependencies. From this, if you are, say, this is my F. Okay, so F plus will contain these two. Okay, this two will be again there. Along with that, any other functional dependencies which can be derived from this. I can say that SSN determines SSN determines D name, D manager SSN. SSN determines D name, D manager SSN, and SSN can determine itself Okay, so all possible, these will see that how different functional dependencies are derived. Okay, so when I am saying about closure of a functional dependency set, this is the functional dependency set say. So the closure of the functional dependency set will include these two along with any other functional dependency that you can derive from these two. Say SSN is determining D number, D number is determining D name and D manager SSN. So SSN can determine D name and D manager SSN. This is a kind of rule. This we'll see next, inference rule. Using that you can do this. SSN can also derive D name and D manager SSN, which is derived by D number. Okay, so this was not there originally in your functional dependency set, but you got this using some kind of rules. Okay, so derive as many as possible set of rules from these two, and combination of all will be the closure of F. Fine. Okay, now next is your inference rules. Inference rules. First thing is, what is inference rules? Okay, that thing which I said that you can derive SSN determining D name and D manager SSN. How you derive this? Now SSN was determining D number and D number is determining this two. So SSN can also determine this two. Okay, this one. So this one I got using some kind of rule. So these inference rule are for that purpose, that using this inference rule you can deduct, or sorry, you can derive some more valid rules from the existing functional dependencies. Okay, so what are the rules? The first rule is written like this. Inference rule 1 is called reflexive rule, which says if X is the superset of Y, then X determines Y. Got? That means if Y is a subset of X, then automatically X will determine Y. That is why we had written here using this particular thing you can write, I hope this is clear. Okay, using this you can write that SSN determines ename. This will be true because here you see ename is a subset of SSN. Say this is my X, no, it is not from this example. This will see here. Here X means is the combination of attributes actually. That means say you have SSN ename salary rate of joining. These are the 4 attributes, suppose in a relation. Fine. Then say this is x. Okay, in this case I can say SSN determines ename because y is a part of x itself. Okay, if I am clear or not, this is y. Okay, these two are both x, so y is a subset of x. Okay, so this will hold true. That means you can write it better in this form, not this one, because this is not x, y. This is x, this is y. But y is a subset of x. That means x contains y. So x can automatically derive y. This is reflexive rule. This is actually also called trivial. Trivial means obvious. It is quite obvious that if an attribute is part of another attribute set, then that set can functionally determine y. Okay, this is reflexive rule. Next is IR2. That is inference rule 2 is augmentation rule.